Hi everyone, myself Ramyabharathi. I am going to take a seminar on multi-terminal VDC transmission. High voltage direct current is shortly known as HVDC. It is an efficient way of transmitting power over long distances without experiencing much power loss. There are mainly three types of HVDC system configurations. They are back-to-back HVDC system, two-terminal HVDC system, and multi-terminal HVDC system. The multi-terminal HVDC system is classified as series MTDC system and parallel MTDC system. The parallel multi-terminal DC systems are further classified into radial multi-terminal DC system and mesh multi-terminal DC system. In back to going to see about multi-terminal DC system. In this type of configuration, it uses multiple transmission lines to connect more than 2 points. There are multiple terminal stations. Each of them are having their own converters connected to the transmission line. Some of these converters act as rectifiers while others act as inverters. The power supplied by the rectifier circuit is equal to combined power received by the inverter stations. This type of network is more complex than a two-terminal HVDC configurations. In the multi-terminal DC system, we can't use the AC circuit breaker on AC side because it will de-energize the whole DC network instead of isolating the line which is having a fault. Therefore, multi-terminal DC system requires multiple DC switchgear so that it can safely de-energize the circuit or isolate the fault part. It is required to balance the system. Series multi-terminal DC system. In this configuration, multiple converter stations are connected in series with each other. Just like in a series circuit, the current flowing through each of the converter station is constant, while the voltage drop may divide among the converter stations. It is nothing but the extension of a two-terminal HVDC system with multiple converter stations in series. These converter stations having the lower capacity than that of the parallel multi-terminal DC systems. This system normally uses the monopolar DC links where the line is grounded at only one point and the other line is connected to grounding capacitor to protect the line from transients. In a series multi-terminal DC system, the power flow reversal can be easily implemented using transients. That is, the voltage was Parallel multi-terminal DC system. In the parallel multi-terminal DC system, there are multiple converter stations, that is the inverter stations, which is also called as load stations, is connected to the single converter station, that is rectifier. The single converter station supplies the power to whole DC network. It is similar to that of the parallel circuit. The voltage remains constant while the current supply may change depending upon the power demand. According to power demand at each load station, the current is adjusted to balance the supply. These terminal stations having the higher capacity in this configuration, the power reversal can be done with either voltage reversal or current reversal technique. If you use voltage reversal technique, it will affect the converter stations. Therefore, we have to implement a control and communication system between these converters. If the power reversal is done using current reversal technique, it will be much easier. This is the reason behind using voltage source converters rather than current source converters. It has a wide range of power flow control in DC network by injecting radial multi-terminal DC system. In this system, it has multiple inverter stations. The radial MTDC system is nothing but a type of parallel multi-terminal DC configurations. If there is a break in a transmission line or removal of a link from the system will cause the interruption of power supply to one or more than one converter station. In this figure, 4 inverter stations are connected with a single rectifier station. A break in when compared to mesh or ring type multi-terminal DC system. Mesh or ring type multi-terminal DC system. In this system, the inverter stations are located with a connected with a single rectifier station in a mesh or ring formation, which is similar to that of the radial system. Whenever there is a break in one transmission line or if you remove one link from the system, it doesn't interrupt the power supply to any inverter stations like radial systems. As you can see in the figure, the removal of any link won't interrupt the power supply to any converter. The applications of multi-terminal DC systems are it connects multiple DC renewable energy farms to multiple power grids. It connects multiple offshore wind farms to power grid. It transfers bulk power from multiple remote AC generating stations to multiple load centers. It allows interconnection between two asynchronous AC power systems. Power supply is reallocated when there is a power failure in one of the generating stations. It is used to offer more power. It offers flexibility for power tapping at multiple points. The Northeast Agra HVDC system. It is the world's first multi-terminal ultra-high voltage direct current transmission link. The transmission line capacity of 800 kV with a converter capacity of 8000 MW, which transmits clean hydroelectric power that is equivalent to generation of 8 large power plants. It covers a distance of 1728 kilometers. The Northeast Agra project is ABB's fifth HVDC transmission link in India. Thank you.